Welcome to Mrs. Rensberger's Magical Podcasts. Today we're going to talk about two-step equations. We're going to be solving equations using the opposite of add, subtract, multiply, and divide. Normally, when we think of order of operations, we do all of our multiplication and division before we do our add, subtract. But remember, when we're solving equations, we're doing the opposites. So therefore, we also do the opposite of our order of operations. So we're going to undo our add subtract first using the additive inverse, and then we're going to undo our multiply divide using our multiplicative inverse. So first we look for our variable, which is on the left side of the equation. To get the variable by itself, we have to get rid of both the 5 and the 9. The 5 and the 9 are snuggling. They're multiplying. So therefore, we're going to let them multiply. We're going to get rid of the add subtract number first. We're going to do the opposite of adding 9, which is subtracting 9. And we're going to do that to both sides of the equation. We're left with 5x, not just x, 5x, because we haven't gotten rid of the 5 yet. And these additive inverses, the positive and negative 9, cancel to 0. And 24, take away 9, leaves me 15. Now I'm going to do the opposite of multiplying by 5. I'm going to divide both sides by 5. This leaves me a positive 1x. But remember, we don't have to write the 1, do we? And then 15 divided by 5, the signs are the same, gives you a positive 3. In this equation, the y is multiplying again, but this time we have a minus 4. We're going to let these two guys multiply, and over here we're going to get rid of that minus 4 by doing the opposite. Going to undo our add subtract first. So that still leaves me a 4y on the left side of my equation, but these additive inverses, the negative 4 and positive 4, cancel to 0. These two numbers have the same sign, so I add them and get 20. Now I do the opposite of multiplying by 4, I divide by 4. Remember, I keep the same sign, so I get a positive y. And 20 divided by 4, the signs are the same, so I get a positive 5. Over here, we have a couple things that are different. First of all, the variable is no longer on the left. Now the variable is on the right. So you now need to get rid of a 3 and a negative 7. And these guys aren't multiplying anymore. It's a fraction. Remember, fractions are division. So remember, we have to undo multiply and divide last. I'm going to get rid of this minus 7 first. Get rid of a minus 7 with a plus 7. Okay? These signs are different. So since they're different, the rules for those integers tell us that we're going to subtract them and keep the sign of the bigger number. Over here, my 7s are additive inverses. A negative 7 and a positive 7 cancel to 0. So now on the left side of the equation, I still have to get rid of this 3. The opposite of dividing by 3 is to multiply by 3. So these 3's are going to cancel out because remember, we have a numerator and a denominator. So I'm left with z, and 3 times 6 leaves me 18. And remember, the symmetric property of equality says if you want, you can put that z in the front and make it z equals 18. Now sometimes you'll have to clean up the equations a little bit before you can solve them. Sometimes there's like terms that must be combined first. Let me show you. You see I have two terms that have w's. Okay? Since they both have w's, we call them like terms. And those like terms can be combined before we do anything else. So I have 4 w's and I have 2 w's on the left side of the equation. So really, on the left side of the equation, I have 6 w's. So now, the 6 and the w are multiplying. To solve that, I would use the inverse, and I would divide both sides by 6. It leaves me with a positive 1w, and 24 divided by 6 gives me a positive 4. On this one, I want you to be careful. Even though you know it's 8 minus 3, remember this is a positive 8 and a negative 3. Keep thinking in terms of integers. These terms are like terms because they both have a t. So I really have 8 t's, and I take away 3 of those t's. That leaves me with really 5 t's on the left side of the equation. So now I can do the opposite of multiplying by 5, which is to divide by 5. And when I do that, I get 1 t, and I get a positive 7. All right, here's another one with subtraction. And this one is going to test your integer rules. Let's see if you know those sign rules or not. Because you can see 5d is positive, 9d is negative. So when the signs are different, even though they're with d's, even though they're terms, like terms, we still have to use our sign rules. And when we combine those, we don't get 4d, we get negative 4d because we keep the sign of the bigger number. So now when I divide, the opposite of multiplying by negative 4 is dividing by negative 4. I have to remember when I divide by the same sign, so I get a positive 1d. Over here my signs are the same, tells me I get a positive 4. Now this one is kind of special. My students look at this and they see this minus and they think, okay, the opposite of a minus is a plus. Okay, we have a little problem with that because are these really additive inverses? Because wouldn't the additive inverse of a positive 7 be a negative 7? And if this 7 was negative, wouldn't it have a negative in front of it? So what's the problem here? I think what happened is that negative, they thought it went with the 7, but it doesn't. It goes with the m. So I'm going to get rid of these plus 7's because that plus 7 is not the additive inverse of 7. The additive inverse of 7 would be a negative 7. So I'm going to subtract 7 on both sides. Signs are different, so I subtract, keep the sign of the bigger number. Now my additive inverses cancel to 0, and check it out. I'm left with a negative m. What do I do with that? There's no number there. Because look, remember, these guys, they had numbers in front of the variable. Those coefficients. They told us what they were, a negative 9 and a 5. Over here, we don't know what our coefficient is. Or do we? Remember, if you don't see it, it's still there. We just don't usually write it. So there's really a negative 1 in front of that m. So I can divide both sides by that negative 1. And that leaves me a positive m and a negative 3. And what I tell my students is if you are left with a negative variable, don't ever leave it that way. You can't solve an equation and be left with a negative variable. You have to change it and make it positive. So if you change the sign on your variable, you have to remember to change the sign on your answer, because what you're really doing is dividing both sides by negative 1. I hope that took a little of the mystery out of your negative variable for you. And I hope you enjoy solving two-step equations. Until next time, thank you.